Okay, so in this video I'm going to take you through two more examples which were exam style on this topic of tangents to circles, just because they're a little bit more demanding than this one that we've done on the previous page here. And in a moment there's going to be an opportunity for you to try some questions like this as well, okay? So it says here that a circle has equation x squared plus y squared equals 314. A tangent to the circle is drawn at the point Q17 where Q is less than 0. Find an equation of the tangent at Q. So the tricky part here is that we don't know what Q is. I think the first thing we're going to need to do is figure out what Q actually is, and then we can repeat this style of question that we've got here. Now I'm actually going to be concentrating on using this formula rather than the y equals mx plus c1. If you do want to use this one, that's absolutely fine. You'll end up with the same answer as me, okay? So the first thing I'm going to do is use the fact that this coordinate is on the circle that we've got here, so I can use that to find out what Q is equal to. Well, this is my x and this is my y, so I can do x squared, which is Q squared, plus y squared, which is 17 squared, equals 314. So Q squared plus 17 squared is 189, but we can check that on the calculator. So I'm going to say that 17 squared is 100. Silly me, I knew it wasn't. I knew something didn't seem right. It's not 189, it's 289. So I can find out what Q squared is by doing 314 minus 289, which is 25, which means that Q is either equal to plus or minus 5 when you take the square root. But because Q is less than 0, that must mean that Q is equal to minus 5. So the coordinate that we've got here is going to be minus 5, 17. That's where we're going to try and find the equation of the tangent. So when I draw a quick sketch and I have my circle, I know that minus 5, 17 is somewhere up here. So this is where Q is, and I'm going to find the equation of this tangent over here like this. So I'm going to begin by finding out the gradient of OQ. In other words, the gradient of this black radius line that I've just drawn. That's going to be the change in y divided by the change in x. Well, because the origin is 0, 0, I can just stick with just actually doing the change in y divided by the change in x. So that's the 17 divided by minus 5. Now what this means is the gradient of the perpendicular, this little symbol I've just drawn, I could have drawn it neater, is just to represent its perpendicular. I'm going to take the negative reciprocal. So negative means we're no longer going to have a negative here at all. So the reciprocal is just going to be 5 over 17. So I'm going to be using this along with the fact that my coordinates Q are minus 5, 17. So my x1 is minus 5 and my y1 is 17. And I'm going to be using the A-level formula, y minus y1 equals m brackets x minus x1. Of course, if you want to use y equals mx plus c and you just sub in x as minus 5 and y as 17, then that's fine. But I'm actually not going to do that one because I want to go a little bit quicker on this and I can get straight to the answer. So it's going to be y minus 17 equals m, which is 5 over 17, brackets x minus x1, and that's x minus minus 5 becomes x plus 5 like this. Now that is technically the answer of the question. It says find an equation of the tangent. I've done it, I can stop there, but I know many of you will probably want it to be written in the standard form. So if I expand the brackets on the right hand side, I get 5 over 17x plus 25 over 17. So y is equal to 5 over 17x plus 25 over 17, 25 over 17 plus 17, because I'm going to add that negative 17 from the other side, and it's 314 over 17. So I'm going to check and see if this has worked by putting it onto Desmos. So it's x squared plus y squared equals 314. So x squared plus y squared equals 314, and the equation that we had here was 5 over, I think it was 5 over 17, 5 over 17 x plus 314 over 17, 314 over, let's just delete this, and hopefully when I zoom out, we've got it all just right. Yeah, so we've got this part here, we've got the minus 517, which was the coordinates of Q, and we have got them intersecting at that point there, so it is a tangent. We've definitely done that whole part right. Okay, so let's have a look at the third example, which is also an exam style question, and it's also a 5 marker. This time it says that C is a circle, centre OO. A tangent to C passes through the points 4, 0 and 0, -8. Find the equation of C. So we're kind of going backwards in this one. I definitely think a diagram is going to be really helpful for when we draw this. So I'm going to draw a quick sketch of some axes, and I'm going to do a quick sketch of, oh, not a circle just yet, because I'm not quite concerned about that at the moment. But I know that the tangent passes through 4, 0 and 0, -8. So 4, 0 is going to be somewhere here, and 0, -8 is going to be down here. So we've got 0, -8, and we know that there's a tangent to the circle that is going through those 2 points like that, which means I should be able to draw a terribly drawn, oh, actually that's come out pretty good. So that's going to be the circle that we're going to try and find. That's what we're going to try and find here. Now I think we can just work backwards with this, because if we can find out the radius, then we might be able to, if we can find out the gradient of the radius, we might be able to find this point where they're intersecting, and that could help us figure out the equation of C. Now remember, the equation of C is just going to be x squared plus y squared equals r squared. So if we can find out what r squared is, we've done the question and we're sorted. So there's an awful lot to think about here. So I think the first thing we should do is we should examine the tangent. We should find out the tangent gradient, and then maybe we should find out what the equation is going to be. So the tangent gradient, m, is going to be the change in y over the change in x. So it is 0, -8, and we have 4, 0. So the change in y will be 0 minus -8. 0 minus -8, and the change in x will be 4 minus 0. Well, 0 minus -8 is 0 plus 8, and 4 minus 0 is 4. So the tangent gradient is 2. And actually, it might be helpful to just find out the equation of the tangent. You might not think to do this now, but actually it looks like it's going to be pretty easy to find out. It's going to be y equals mx. We just need to find out the c. We just need to find out what the y-intercept is. And the y-intercept is -8. So we get the 2x minus 8. Now we also know something about this line, because if I can find out this point here, I should be able to find out the length of this line, because I can sub it in and find out what r squared is. So what I want to try and do is I want to find this coordinate. Now this is where we're going to find out the solution to some simultaneous equations. What we're actually going to do is we're going to imagine that this line is a lot longer, and we know the equation of the black line. The equation of the black line we've just worked out is y equals 2x minus 8. So we just need to work out the equation of this line, and then if we solve them simultaneously, we'll find this coordinate, and we can substitute it in here to find out what r squared is. So I think the equation of this line, we know that this equation has gradient what? What do you think the gradient is of this? It has gradient, well, it's going to be perpendicular, right? So this one has a gradient of 2. So this is going to be a negative reciprocal of 2, which will be -1/2. So we're now going to say that the equation of sort of through this point is actually going to just be the, what should we call this? We'll call this the equation of the line through the origin and the point. Let's just call it this line equation. Let's just write it down. It's going to be y equals -1/2x is one of the equations in red, and then the other one that's in black is y equals 2x minus 8. So all we need to do is solve these equations simultaneously. So we're going to solve these equations simultaneously. This is a really easy one to solve simultaneously. You don't need to do anything like elimination, because we can just replace y with a half x in this one. Sorry, -1/2x. So we can say that -1/2x equals 2x minus 8. So I'm going to plus the 8 to this side, and I'm also going to do the 2 plus the half. The 2 plus the half, well, that's 2.5 or 5 over 2, so that's 5 over 2x. So now I'm just going to solve this equation. I'm going to multiply both sides by 2 and then divide by 5. So x is equal to 16 over 5. Now I should very quickly be able to find out what y is equal to, because I know that y is equal to -1/2x. So y is going to be equal to -1/2 multiplied by 16 over 5. Well, it's just a half of that, so it's minus 8 over 5. This is where it might be easier to have it as decimals. I wonder if I can just sort of squeeze this into the page up here. So we now have the coordinate, this point that I'm going to just call P. This point P is 16 over 5. 16 over 5 is, as a decimal, 3.2. And minus 8 over 5 is just going to be, as a decimal, 1.6. Minus 1.6. So if we want to find out what the radius is, this is x and this is y. We know that x squared plus y squared equals r squared. So the 3.2 squared plus minus 1.6 squared is equal to r squared. So I'm just going to calculate that. I'm going to do 3.2 squared plus, I'm not going to be bothered to put the brackets, I'm just going to put 1.6 squared because I know it will be the same. 1.6 squared is the same as minus 1.6 squared if you use brackets, is equal to 12.8. So we now know that r squared is 12.8, hence the equation of the circle is x squared plus y squared equals 12.8. That is the final answer to that question. So maybe I should have given you a little bit more space to do this, but as a quick reminder of what we did here, we started off, this is a very challenging question, is we found out the gradient of the tangent line, which was 2. And so we also were able to find out the equation of this line because we had the y-intercept here, but you might need to find the equation of the line. We then knew that the line passing through the origin and the tangent point had a gradient of minus a half because it was the negative reciprocal. And we knew that if we found out where they crossed, we would find out a coordinate that is on the circle. Once we have a coordinate that is on the circle, we can substitute it into the formula for a circle x squared plus y squared equals r squared to ultimately find out what r squared is equal to, which gives us the equation of this. Okay, I'm very quickly going to just show you that this does work. So x squared plus y squared equals 12.8. So x squared plus y squared equals 12.8. And the other equation of the line that we worked out was 2x minus 8. So we're going to do 2x minus 8. And it does have a tangent here. And we can also see it passes through 4, 0 and 0 minus 8. Okay, so on this next page here, I've got 3 questions that are exam style for you to have a go at. In the next video, I'm going to do these 3 exam questions, but they are very, very similar in style to this one, and example 1, which was from the previous video. I think you can probably agree with me. This is a challenging topic, so take your time, rewatch any of the video if you need to, and wishing you best of luck with these questions. I'll come back in a second to go through them. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.